Today's topic is radical equations. Radical equations are equations that have radical signs. As you can see, all the equations on this handout, they are one example of what a radical equation looks like. To solve a radical equation, we will use the same basic idea, performing inverse operation to isolate the variable. And here we have a property that will help us do that because we have radicals. So the main idea is that you're going to isolate the radical part, put it on one side of the equation, and then everything else on the other side. And once you have done that, you can apply this squaring property right here that I'm highlighting right now. If you square both sides, you will get rid of the radical sign, which will help you continue with the problem solving. So let's look at some examples. Section 1 is solve radical equations with one radical. And as I said before, the first thing to do is isolate the radicals, right? So where is our radical? It's right here. This is our radical. So we need to isolate that. The inverse operation in this case will be subtract 5 from both sides. And this will give you radical 2x minus 3 equals negative 5. And do we need to square? Normally we do, right? Normally we will square both sides and continue. But for this one, I would just say there is no real solution. This is because for a square root, it can never be negative in the real number system. When it's negative, it's imaginary number, which we will cover in the next handout. But for today's handout, if you have a square root that turns out to be negative, you will say no real solution at the end. So that will be the answer to this one. Go ahead and practice with practice 1. Okay, so hopefully you did this one. It's going to be the same thing, right? This one is also no real solution. You just need to move that positive 2 to the right-hand side, and you will see that. Example 2. Example 2 will first identify the radical, which is right here, and then you perform inverse operation. We need to move this negative 5 to the right-hand side, so we plus 5 on both sides. And this gives us radical 3x plus 2 equals 5. And this time we are going to continue. This is because we get a square root that's not negative. So we can square both sides. All right, once we square both sides, on the left-hand side, you're going to apply the property that I highlighted, which is right here. When you square a radical, you cancel out the square root, right? So the square root and the square cancel out, you just have a left, which is the radicand, the expression that's inside of the square root. And over here, our radicand is 3x plus 2. On the right-hand side, 5 squared, 25. All right, we get a very simple linear equation. You should know how to solve. Inverse operation, subtract 2 from both sides. This will give us 3x equals 23. And then divide both sides by 3. We get our potential solution. I use the word potential for a reason, which I will explain later. So it's 23 over 3. I say it potential solution because there might be a chance that this is incorrect, especially when we deal with the radicals. This is because when we solved using this method, we squared both sides of the equation. When you square both sides of the equation, chances are you're bringing in some extra solutions in some cases. And that's why it is very possible that the solution that you got might not work. So how do you check? You plug this back into the original equation. So the original equation is radical 3 times x, right? So you plug in the value of x, which is 23 over 3, and then you copy the rest of the equation. And I will also put a question mark above the equal sign because we're checking if this 23 over 3 is a solution to the equation. I don't know yet, so that's why I'm checking. And in order for it to be a solution, the equation has to be true. So let's verify this. 3 times 23 over 3, the 3 and 3 cancel out. It's just going to be 23. Plus 2, that's 25. So this is square root of 25, subtract 5. And then we're checking if this is 0. And square root of 25 is 5. So 5 minus 5 is 0, right? That means our solution is correct. We can box this. And that's example 2. Let's do practice 2 as a practice. I'm going to give you the solution. Okay, moving on to example 3. Just remember the main idea. Actually, let me write down the main idea, right? Main idea. Put it on the top. The main idea is that you need to isolate the square root. That's the first step by doing inverse operations. And then the second step, you're going to square on both sides of your equation. And then step number 3 is solve the equation. You will get either a linear equation or a quadratic equation for most of the time. And then step number 4 is check. That will be the main idea in this section. And also for the entire handout, actually. Okay, let's apply this main idea to example 3. First, identify the square root, right? The square root is right here, so I need to do inverse operation to isolate this. And the inverse operation will be the opposite of plus 2, which is subtract 2. And you do that on both sides. And this will give me square root of x minus 2 equals x minus 2. Notice that on the right-hand side, x and negative 2, they are unlike. You cannot combine them. You just put them together. And now we're going to square both sides. So you might ask, is there a case where this could be no real solution? So right now, we don't know. This is because the value of x is unknown. So we don't know if x minus 2 on the right-hand side is positive, 0, or negative. As a result, we will proceed as planned. So I'm going to square both sides. And then on the left-hand side, apply the property on the top that I highlighted right here. You square a square root. They are inverse operations. You will cancel them out. You will have what's inside of the square root, and that's x minus 2, equals, on the right-hand side, x minus 2 squared. So you could do FOIL, or you could apply formula, or you could apply the area model. As a review, let's actually do the area model, right? X minus 2 times x minus 2. So I'm going to do a box, and I'm going to divide each side by 2. This is because you have x and negative 2, so there are 2 terms. And then I'm going to write down x, negative 2, x, negative 2, to represent the right-hand side, which is multiplying x minus 2 by itself. It's called an area model because we calculate the area of each of the box. First box, x squared. Second box, negative 2x. And then third box, negative 2x. Last box, positive 4. Once you find out these 4 products, we add them together. We will get x squared minus 4x plus 4. So this is using the area model. Let's write that here. Okay, as you see, we have a quadratic equation. So for quadratic equation, I'm going to move everything to one side of the equation and 0 on the other side so that I can apply factoring to solve. I noticed that x squared is positive on the right-hand side. That means I'm going to do inverse operation to move everything to the right-hand side. So subtract x plus 2. That would be the inverse operation. And then you do the same thing on the right-hand side. Subtract x plus 2. And then on the left-hand side, we have 0. On the right-hand side, let's combine like terms. We have x squared minus 5x plus 6. And now we're going to factor the right-hand side. So 0 equals two pair of parentheses. To get x squared, we have x and x. And the product is positive, but the middle is negative. So I know that the two numbers must be both negative. The correct combination will be -2 and -3. So you could pause the video and think about why that's the case. And now we can apply the zero product property, right? We have a product that's 0, which means each of them could be 0. So x subtract 2 could be 0, which leads to x is 2. The other is x subtract 3 could also be 0. And this leads to x is +3. And then before you box this, don't forget to check, right? So let's check if they are correct. I'm going to write it maybe on the right-hand side. So if you're running out of space, you could just write on a separate piece of paper. To check, you plug these two values into the original equation. So we have square root of 2 minus 2 plus 2 question mark equal sign 2, right? So I simply replaced x with the first value of my x, that's 2. And I got this equation. Let's check, see if it's right. Square root of 2 minus 2, that's square root of 0, which is 0. So it's a 0 plus 2. It's asking, is that 2? It is. So that means the first one is a solution. I'm going to box this. And then do the same thing for the other one. X equals 3. So that means square root of 3 minus 2 plus 2 equals question mark 3. This time I replaced x with the second value of x, which is 3. Let's check, see if it's right. Square root of 3 minus 2, which is square root of 1, and that's 1. So it's 1 plus 2, and we're checking if that is 3. It is. And that means the second solution is also correct. So I'm going to highlight and box both of them. All right, I'm going to give you the answer to practice 3. Make sure you use it as a practice to test your understanding. So for practice 3, the equation... Oh, actually, I don't have a solution. I do. Never mind. I believe it's this one. Okay, let's move on to example 4. Example 4, we have the radical part as well, but we also have some other numbers that we need to get rid of. So first, I'm going to highlight or box or circle this radical part and then perform inverse operations. The first inverse operation will be plus 16. So a plus 16 on both sides. And I will get 2 square root of 4x plus 4 equals 32. And then I still need to isolate the square root. Let's use a different color. So I still need to isolate this piece, right? The operation that I have right here is 2 times. Is 2 times. So there is a multiplication going on right here. That means we need to divide both sides by 2 to isolate the radical part. So divide both sides by 2, and this will give me square root of 4x plus 4 equals 16. And now I have my square root isolated. I can square both sides. Make sure you use parentheses. On the left hand side, applying the property, it's just going to be what's inside of the square root, 4x plus 4. And then on the right hand side, 16 squared, you could use your calculator, 256. All right, so this is a simple linear equation you should be able to solve. Inverse operation, subtract 4 from both sides. And that will give us 4x equals 252. Divide both sides by 4. We get our potential solution, x equals 63. And before you box this, we're gonna plug this value back into the equation and check, see if this satisfies. So I'm gonna do 2 square root of 4x. Our x is 63, so I'm gonna do 4 times 63 plus 4 minus 16, and then equal sign question mark 16. So this will be the expression on the left hand side, and we're checking if it's 16. Let's verify that. So I recommend use a calculator if you can. So let's see, 63 times 4, that's 252, plus 4, 256. So this is 2 radical 256 minus 16, question mark equal sign 16. And 256 is the square of 16. So if you do a square root, it will give you 16. So we have 2 times 16 minus 16, question mark equal sign 16. 2 times 16 is 32. 32 subtract 16, is that 16? It is. So we check that this value 63 is a solution. Let's box this. Okay, use practice 4 as a practice. I'm gonna give you the solution. Second page. So the first page is the entry level. This is because all the equations contain just one radical. As you can see, all these examples, you don't see multiple radicals in the equation. It's just one, right? It's just one square root sign. And then on the second page, we have equations that have 2 radicals. Example 5. The good news about example 5 is that the radical is already isolated, right? If you look at the left-hand side, it's by itself. If you look at the right-hand side, it's also by itself. And that means we don't have to isolate it. We just apply the squaring right away. I'm going to square both sides. This is how you get rid of the radicals. And that will give me 5x minus 4 equals 2x plus 5. It is a simple linear equation. Let's do inverse operation to isolate x. I noticed that the coefficient of x is greater on the left-hand side, so I'm going to move this 2x to the left-hand side by doing subtract 2x on both sides. And this will give me 3x minus 4 equals 5. And then we add 4 on both sides. And I obtain 3x equals 9. And finally, we divide both sides by 3. We get a potential solution. X is 3. Before you box, we're going to check. So remember, always check your solution for radical equations. Let's plug it in. Square root of 5x, so 5 times 3 minus 4 equals sign question mark. And then we have square root of 2x. That's 2 times 3 plus 5. And let's see. On the left-hand side, 5 times 3 is 15. 15 minus 4 is 11. So this is square root of 11. And we want to see if this is the same as the right-hand side. 2 times 3 is 6. 6 plus 5 is 11. So this is also square root of 11. Looks like it's true. So we're going to box this solution. X is 3. Let's use practice 5 as a practice. I'm going to give you the solution. For this one, it's no real solution. Oh, let me change the color. So what happens here is that after you solve and check, you will notice that the checking doesn't work. So that's why your conclusion will be no real solution. Okay, moving on to example 6. Example 6, we have 2 radicals. And if you look at the radical on the left-hand side, it's not by itself. So you could do an inverse operation and isolate that. But on the right-hand side, we have another radical that is by itself. So if you have two radicals and one of them is by itself or both of them is by itself, you can simply just go ahead and square both sides. You just need one of the radicals completely isolated, and then you're able to apply today's technique to solve the equation. Let's square both sides. So don't forget that you need parentheses on the left-hand side, and on the right-hand side, I'm also going to put parentheses, and I'm squaring both sides. It's not multiplying by 2, by the way. It's squaring both sides. So on the left-hand side, let's use the area model that I talked about earlier to calculate. So I'm going to do a box. And I'm going to divide the sides by 2. And then write down the number. So we have 3. We have negative radical x. And we're multiplying this by itself. So the other sides will also be 3 negative x. And now I'm going to calculate the area of each box. 3 times 3 is 9, so that's the first one. And then 3 times negative x, negative 3 radical x. Negative radical x times 3, negative 3 radical x. And then finally, negative radical x times negative radical x, that will be positive x. And then we're going to add these 4 products together. So I'm going to write x first. We have x, and then I have the diagonal, negative 6 radical x. And then finally, I have the first box on the top left, positive 9. So this will be the sum of the total area. Let's write that down on the left-hand side of the equation. Okay, equals. On the right-hand side, we have x minus 3. That would be after you apply the squaring property. Okay, so this is the equation that we have. And I'm going to perform inverse operation. So I noticed that there is x on both sides. And they have the same coefficient. That means they will cancel out. And then for the remaining equation, I'm going to subtract 9 from both sides. I'm going to keep the x on the left-hand side. So subtract 9 on both sides. And again, your job is still isolating the radical, right? So the radical that I'm isolating right now is right here. So that's why I subtracted 9 on both sides. And this will give me negative 6 radical x equals, on the right-hand side, you have negative 3 minus 9. You could use your calculator or you could do mental math. It's going to be negative 12. And again, we're still isolating this piece right here, which is square root of x. And there is a multiplication going on right here. Oops. There's a multiplication going on here, which means we will divide both sides by that coefficient, negative 6. So I divide both sides by negative 6. And this will give me square root of x equals 2. And now we have the second radical isolated. We're going to do another squaring both sides. So as you can see, it's the same idea. This will give us x equals 4. And then before you box this, let's check, see if this is correct. So plug this back into the original equation. 3 subtract radical x, which is radical 4, equal sign, question mark, square root of 4, subtract 3. And then we're going to check, see if it's right. On the left-hand side, it's 3 subtract square root of 4 is 2. And then we're checking if this is the same as on the right-hand side, which is square root of 1. And then we could do one more step right here. 3 minus 2 is 1. Is 1 the same as square root of 1 is also 1? And that is correct. That means we can safely box or highlight our solution x equals 4 right here. Okay, let's use practice 6 as a practice. I'm going to give you the solution right here. Last section, radical applications. So radical applications are just word problems that uses formulas that contain radicals. That's basically what it is. Example 7. On Earth, if an object is dropped from a height of h feet, the time in seconds it will take to reach the ground is found by using the formula T equals radical h divided by 4. A helicopter dropped a rescue package from a height of 1,296 feet. Find how many seconds it took for the package to reach the ground. And this one is just a plug-in question, and the formula gives you the time it takes for an object to reach the ground. And we have the height, right, h, which is 1,296, and we're looking for t. So as a result, we simply plug it in. T equals radical h, so that would be radical 1,296 divided by 4. So this will be the expression that we use to calculate, and I highly recommend you use your calculator. On the top, it's going to give you 36. So it's 36 divided by 4, and that's 9 seconds. And I'm going to highlight this. For this one, you don't really need to plug it back and check, because it's not an equation. We're just using the formula to evaluate an expression. All right, I'd like you to practice with practice 7. It is a very similar problem. Simply just plug it in. But I'm going to give you the final answer so that you know whether or not it's right. It is required to round your answer for this one, so you're going to keep one decimal place, which is 42.7 feet. And thanks for watching the video.